All right. Well, next up, I am really excited to introduce to you Ryan Benson from Google. Ryan Benson and I have actually had an interesting kind of overlapping path throughout our careers. Kind of had a couple of places where we worked together, even though we were not physically in the same spot. But right now he's with Google. He's a security engineer there, and he's going to be talking about a tool that is near and dear to my heart in the network forensic world called Unfurl. And it's a tool that he'll be able to talk through, and it's also publicly available, really pulling out all the data that is available in those URLs. So this is definitely a library I've been watching, or utility I've been watching for a long time. And I'm really pumped that we've got a talk on it, because I know there's a lot of things that you've been working on with it. So I'll go ahead and turn it over to you, Ryan. Thank you very much for joining us, and the floor is yours.
Hey, thank you, Phil. All right, so as this kind of shows here, I'm going to be, and from the nice introduction, I'm going to be talking about Unfurl. And so from the tagline here, Unfurl is a tool that lets you extract and visualize data from URLs. So there's lots of tools out there that maybe it's like some kind of threat intel tools that can take a URL, or a domain or an IP, and look it up in some big database and tell you more information. Or maybe there's a tool that will kind of crawl a website and tell you what technologies it's built with, like what kind of stack it has, any tracking codes embedded in it, or maybe enumerate all the subdomains or the pages. Like those are all great tools, and Unfurl is none of those things. Okay, Unfurl is a tool that focuses on just the data that's in the URL, like actually the string that makes up the URL, and pulling out every bit of information that it can just from that URL and turning it into a directed graph. And so, okay, what does that actually mean, a directed graph? I think the easiest way to explain that is just to kind of show you. So here we have Unfurl, and this is the interface. It's pretty simple. There's just a logo. There's a little box and a button that says Unfurl. And so you put the URL in there, and then you click Unfurl. And then let's see what happens here. So this is what you get. Sorry. So this is what you get. So you take the URL, and it becomes the first node there. It moves down from the box and becomes the first node in this directed tree, or this directed graph. And so this is set up like a tree. And so that first node is called the root node. And the way Unfurl works is that it runs, so there's the core kind of Unfurl code, and then there's all these parsers. And the parsers are kind of like the meat of like what Unfurl actually does. And Unfurl takes every parser and runs it against every node. And if the node, or if the parser is applicable to that node's content, it will create a child node of some subcomponent. So it's trying to break up a big thing into a smaller thing. That's kind of the general gist of what Unfurl does. So this first kind of contrived example, we're taking this URL and we're breaking it up into its subcomponents. So first here we have, it breaks up, first we have the scheme, right? So HTTPS is one node. The next node is the network location, so www.example.com. Then we have the path, and then we have, at the last there, we have the query string, kind of split off. And so Unfurl, again, it runs all of its parsers against all those child nodes. And so for HTTPS, there wasn't really anything else you could parse out of that, so there's no child nodes. If you look at the network location, it pulled out the subdomain and the main name, and then the TLD. It took the path and broke it up into the different segments, and then it kind of split the query string into its kind of pairs right there. And so this is a very, again, simple example, but that's kind of just the general idea of how Unfurl works with URLs. And so, okay, why URLs? So I do a lot of investigations, right? That's my job as a security engineer. And pretty much every investigation these days, no matter like the flavor, involves like internet related artifacts, right? If you're looking at an insider threat case, like what kind of activities a person did in their web browser is obviously important and critical. If you're looking at an intrusion case, any kind of network infrastructure that the attacker has or used, or where any payloads came from is important. If you're reverse engineering malware, you might find network indicators in there, or maybe the malware is communicating back to some server using some kind of URL parameters or something like that. So URLs are kind of, I think, the most common, the least common denominator in a lot of these kind of internet cases. And so I think I want to get the most I can out of a URL. I think they're a little bit overlooked as far as their utility. Because also, if you have more data, like if you're looking at somebody's web browser history, right, you probably have a whole mess of SQLite databases, cache files, and preferences, and JSON files, and all this good stuff to look at. And you should definitely look at that, right? You should use all the evidence you have. But what if you just have like a firewall log or a proxy log, or you carved some URL from memory, or you found it in an allocated or something? We can still get a lot of information just from that URL. And so that's kind of where Unfurl comes in. And then of course, everybody loves an asterisk on a statement, right? So we'll get to this kind of at the end of the presentation. Okay, so as I kind of go through this, I have some, I guess, general principles that I kind of apply to my investigations, and they're kind of reflected in Unfurl too. So I'm going to reference them as we go. So the first one that kind of came out of that was use what you have, right? So if you have a whole mess of extra data, you have a full browser history and full profile and all that stuff, you should definitely use it, right, for your investigation. But if you just have a URL, like, you can still use that. You should use what you have, and we can still get value from it for an investigation. Okay, this is the part where if I could actually see the live audience, I would quiz you and say, hey, can anybody tell me what this is, any information about it? So, I mean, I can't see you, but you can still feel free to speak out what you think this is. Okay, there's an appropriate pause. All right, so if you said it was a timestamp, you'd be correct. Maybe you're really familiar and stare at these things a lot, and you thought, oh, maybe it's a Unix epoch kind of timestamp because it starts with a 1.5, so it's probably relatively recent. Maybe if you really stare at these a lot like I do, you thought there was maybe some fractional seconds because it looks a little long to be a normal epoch timestamp. And yeah, those things are all right. So this is a Unix epoch timestamp with milliseconds. And so Unfurl just, again, it has one of the many parsers it has is for timestamps. So there's that kind of that blue bar of the clock is kind of telling you that the first node, that number was parsed into human readable timestamp. And if you want more information about that timestamp, how it was parsed, if you can hover over each node, it'll tell you more information about it. This is kind of a general design philosophy for Unfurl. Like these graphs I'm showing you right now are pretty simple and small, but as they get bigger, I don't want to cloud, I don't want to confuse the valuable bits of information with the extra kind of supporting information. And that's obviously a design choice and subjective on my part. But I try and balance what I think is useful for the analyst versus what just might be more extra like trivia kind of stuff. And so some information I hide away in these hovers. So if you hover over a node, you can get some more context around something. In the same way, if you hover over a link, it'll tell you, like the blue link with the clock, it'll tell you what kind of parser ran this. And so again, with that, like this is a number that Unfurl parsed as a timestamp. And so one of the things that Unfurl does, not to be cluttered, is it only parse things that are what I call a plausible timestamp. So for this context, that means a timestamp that is between 2015 and 2025, right? Because there's lots of numbers that you could parse as a timestamp correctly, but it might show like, 2070 or, 1972 or some things that like are probably false positives. So again, that's the balance of trying to show you just the most relevant information in the interface. Okay, so the second kind of general principle is automate, right? So that translating a timestamp from a number to a human readable timestamp, that's not rocket science. There's probably a dozen or 5 dozen tools that can do that for you. So maybe using Unfurl just saves you 5 seconds. You don't have to copy and paste a number to a different tool. You don't have to try and decipher or click through the options and see what kind of timestamp format you think it is. But again, it's not rocket science. It's pretty simple. But these little automations, I think, are kind of what I call Unfurl's like building block approach. So for one, if you have a building block, it just doesn't take you don't go just from URL to like some big complicated answer. It shows you, Unfurl shows you all the intermediate steps. So kind of, it's like a show your work approach. So it lets you see what Unfurl is doing. It helps you understand, I think, more what's going on in these transforms. And it also lets you, double check and make sure it's not making a mistake, right? All software has bugs. And again, also, I hope it'll help you learn a better bit about what Unfurl is doing. So then, I guess, also for your knowledge, but also if you have to explain this evidence to somebody else, which you probably will if it's an important case, you have a better understanding about what happened and why, and not just, oh, a tool told me this. Yeah, so these automates, the other cool thing I think with these building blocks is just because the automations are simple and small doesn't mean they're not valuable. You guys are all familiar with CyberChef, right? I think that really nicely illustrates the power of when you chain a lot of small automations together, you can get really powerful results, right? So I think the small automations are kind of like the greater than the sum of their parts situation. Okay, back to audience quiz time. Can you tell me what this is? I mean, I can't hear you, but what does this look like? If you said a UUID, you are correct. But can you tell me anything else about this UUID? Again, if you stare at these things long enough, you could tell me it's a version 1 UUID, right? And so the little cheat sheet for that, or the shortcut for that is look at the third grouping of numbers, the first digit, that happens to be a 1. So this is a version 1 UUID. And again, more background about UUIDs. This version 1 UUID is generated based off the system's the time and the MAC address. So again, that's kind of cool. But yeah, so time generated MAC address, can we pull that out from the UUID? And in fact, we can. It's all just encoded in there, so you know how to pull it out. You can pull those out. And this is where, again, a little bit more of that building block approach. So from the UUID, the first node, this version 1 UUID is based on time and MAC address. That's what I call a descriptor node. Sometimes it just, I think, is information that's relevant to the analyst. And so it's just, there's no data in there. It's from the artifact. It's just explaining a little bit more about what it is. And these next two nodes, it tells you the time generated and the MAC address. But you notice the time generated is just a number, right? And the MAC address is just a MAC address. But can we do more with that? And yes, we can. So again, with Unfurl, it runs all the parsers it has against every node. It even ran all those parsers against the descriptor node, but I mean, there was nothing to parse there, so it didn't produce any results. But the timestamp parser picked up that time generated as a timestamp and translated it. And there's also a MAC address kind of translator. So it looks up the first half of a MAC address can tell you the vendor of the MAC address. And so it does that kind of translation too. And this is the first example of a graph where we have different colored edges or links in this graph. Like the very first example was all that very simple URL parser. So it was all this kind of base black. It's kind of like what I call it the base parser for Unfurl. The UUID parser is in this kind of yellow gold color. And then the blue is the timestamp and the red is the MAC address. So again, at a higher level, hopefully you can kind of glance and get a small idea about what kind of transform each of these parsers were doing. And timestamps, like digital forensics, we love timestamps. So anytime I can pull out a timestamp from an ID, like a UUID, that makes me really excited. So my team at Google, we work on a lot of open source forensics tools. One of them is Plazo, which is basically tries to pull the timestamps out of everything you can imagine. And then TimeSketch is a nice way to view all those timestamps that you extracted. So anytime I can find a timestamp as a forensic analyst, I'm pretty excited about it. Okay, back to quiz time again. What is this guy? If you said a UUID, like the last one, you'd be correct. And again, what's the next step? So I'm looking at the third grouping, first digits, that's a 4. It's a version 4 UUID. And unlike the version 1 UUID, the version 4 is random. There's no timestamps, there's no fun stuff hidden in it. We can't pull anything out of it. So, that's sad. And this is also unfortunately the most common UUID you'll find kind of used today because there's a good reason why you want to have a random ID instead of extracting things from it. But so the description node here, version 4 UUID is randomly generated. Unfurl is telling you that, right? But I mean, I don't think that's a complete waste. I still think that is helpful because the next kind of principle is recognize dead ends. Right, so Unfurl could tell me that this 128 bits encoded as a string here, which is a UUID, is random. Like there's no further value in there. Stop thinking about it, move on, move your investigative focus and your brain power to something where you might actually get some more results. So I think recognizing dead ends in your investigation is a good way to keep focused. And it's also a great way to just kind of keep you on track. So I think unfurl, denoting when something is random or there's nothing in there, I think is still valuable. So like we just looked at UUID v4, which is probably the most common example of this. So those are random, but also looking more, if you ever looked at like Medium, the blog site, there's like a little hash attached, a random looking string attached to the end of the URLs for tracking. That's a random number, that's random. So there's nothing juicy hidden in there. I was recently looking at some Spotify URLs and there's this big long hex looking string in there, and that's also is just a random number, nothing hidden in there. But it's good to recognize these, and so I can stop like thinking about what it is and move on to something that could actually help my case. Okay, enough with these fun kind of made-up examples. We're at the DFIR Summit, and we all love Twitter. Hopefully we're all tweeting as ourselves today. And so here's a little example of looking at a Twitter URL. All right, so we have, again, the simple unfurl interface. You just take, this is a URL of a tweet from my friend Phil Moore, and let's just put that in there and click the unfurl button. Okay, so here's what it looks like. So we have at the top, we kind of have the base URL parsers breaking out the domain name Twitter and then like the path. And then the next time the URL parser is breaking up the path into Phil Moore and then status and then this long number. And that long number is split up into some sub things. So let's zoom in on that just a little bit. Okay, so Twitter. I'm assuming most people are familiar with Twitter. So back in the day, in 2010, they were growing a lot and they needed a kind of ID structure. And they wanted these things to be generated quickly and in a distributed way. So on lots of computers with no coordination. And the other wrinkle is that they wanted them to be roughly sortable by time. So if the number is smaller, it's an older tweet, or it's an older object. If it's a larger number, it's newer. And so they came up with a scheme called snowflake. So this number is a Twitter snowflake. And so from the snowflake, the first part of that number is a timestamp, which we can extract. And then for the kind of uniqueness, the distributed part of the snowflake, we can pull out some machine IDs, some sequence numbers on the right kind of the snowflake. And again, like I could have gone from the snowflake, pulling out that number and translating it immediately inside that to a timestamp, but instead I left it as just a number, and then Unfurl picked up that it was a timestamp and then translated it for you in a human readable kind of way right there. Okay, cool. So we pulled a timestamp out of the snowflake. Great. What does that timestamp actually mean? So let's try and do some looking. So this is that's the tweet, the URL of the tweet at the top, and then here's the content by Phil of that tweet. And then if you look at something on Twitter, you kind of see at the bottom, it can tell you the time it was sent and like the app it was sent with and whatever, right? So here we have 10:34 p.m. And then here we have the node from Unfurl, and accounting for time zones, Australia versus Pacific time. So this time is when the tweet was sent. So now that's kind of cool. We can tell just from a URL, no API lookups, no anything like that. We can tell when a tweet was sent, just from information embedded in that snowflake. So I think that's pretty neat. And let's actually go back and look at that tweet. So Phil has done a lot of great work on finding stuff hidden inside, or not hidden, but decoding things inside Google URLs. And in this tweet, he is talking about a new one he found, the SXSRF parameter. And he's saying it looks like a bunch of kind of stuff, and then a colon, and then a number that looks like an epoch timestamp. And so, again, Google URLs, right? I couldn't do this talk without talking about Google search URLs. They're probably the best example, the most common example of huge, big URLs you're going to see on the internet that probably have a bunch of fun stuff hidden inside them. And you would be correct. But so I think what I used to do and what I still do is the first thing, as I look at this URL, I see it's google.com/search, and then I just scan it looking for the Q equals to find out what the person searched for. Right, and I imagine that's probably the approach that most people take. You can just find the Q for the query and look at that and see that the person searched for DFIR.blog space unfurl. So again, I think that's probably the most valuable part of this URL, right? Knowing what the person searched for and the fact that it was Google search, but it's by no means the only thing that we can pull out of it. So let's throw this puppy into Unfurl. Okay, so I know you can't read that. It's very tiny, but there is a lot of stuff in this URL. So we'll zoom in on the pieces. All right, so here we have kind of the base URL parser. It just pulls out the domain and then /search, but all the good stuff that we kind of care about in this is in the query string. So this is, we're going to step through some kind of examples from the query string here. So we have the first, we just parse out the Q, right? So Q for query is DFIR blog space unfurl. So that was simple. It just did the URL escape, translating that plus to a space. But again, it pulls out this query so you can easily see what the person searched for. There's another query in there, another parameter in there called OQ, which is the original query. This is typically the same as the query, but it can be different if you use like a suggestion or other things like that. All right, next we have the SXSRF parameter that Phil was talking about. And just like he said, we split off that first part. Don't know what it is. So we split that parameter on the colon. So the first part is on the left, and the second part is that long number. And then again, Unfurl picked it up that it was a timestamp, and so it translated it. Over here, we have another parameter. So the EI parameter, there's a lot of good research done by people on this. So we know how to split it up into these 4 different components, but right now we only know what the first part is. I mean, we know that that it looks like a timestamp. The other 3, we're not sure what those are. So Unfurl can split those out. You can show you those numbers in case maybe you're the person to figure out what those 3 things mean. But then it also translates that first one into a timestamp. And then the VED. If you've looked at these before, VED is one of my favorite kind of parameters. This is all about how somebody clicked on a link. So this first parameter is the link index that it pulled out. This tells you how far down the page. This was like the 11th link on the page the person clicked on. The link type, there are, like this one is 60,000 something. There are lots of link types. If it's one of the ones that kind of the community has researched, Unfurl will translate the link type for you, like if it was a video or a book or a news or whatever it is. Then we have the timestamp. Again, it's just pulled out as a number. Unfurl picks it up as a timestamp and translates it. And then we have these other 2 parameters that we don't know what they are, but they're again just kind of shown there for completeness' sake. And then this one, the GS_L parameter from Google search is pretty neat. Again, I think Phil did it. Maybe some other people did some research on this. This is a whole mess of parameters. They're kind of separated by a period. And if there's no parameter between the periods, that just means the answer or the value is null. There's at least 26 of these. I think we only have an idea what maybe 6 or 7 of them mean. And so those are just the ones that Unfurl shows you. But this is all about how someone used the search thing. So it tells you they selected search terms using the keyboard, like using the enter key. It can tell you how long someone was on the search page in total before they started typing, how long before they selected the search box. So all this really nifty kind of like, I mean, it's basically trivia, right, about what a person did. But I mean, this stuff, like it's trivia and it's not important until it's really important to your case, right? Every case is different. And sometimes these little bits of context and little bits of help can make or break a case, right? Or can at least be really valuable corroboration of some other finding that you have, right? So I think all this neat little stuff is pretty fun. So I'm just kind of making it easier to see these again. I'm pulling those 3 timestamps we talked about in a little bigger view. So we have the SXSRF, the EI, and the VED. And looking at these, what's interesting is they're all approximately the same time, but not exactly. It's also interesting that they all have different levels of precision, right? So the first one is a millisecond timestamp. The EI parameter is just to the second, and the VED is actually to the microsecond. So again, I think it's interesting that these all are, again, they're each individual points pointing to a timestamp. I think from research, we've kind of concluded that this is the time of the search session started, which many times is very close to when the search itself happened, but that's not necessarily always true. So again, all this stuff is, all these research about what these parameters mean is all from the community trying to figure it out, right? Because these things are not open source, they're not published by Google what they are. So again, this is just our interpretation, and Google could also feel free to change these anytime, right? So that will, again, this is all just kind of with a grain of salt. So yeah, that's kind of cool. We got 3 parameters, we got 3 timestamps hidden inside that long string that we started with that we didn't know before, plus all extra fun timing stuff in there and how they clicked on a link and etc. And so, yeah, so this is the kind of 4th principle I want to say is details matter, right? So we started with that Google search. We can skim it and find that I searched for DFIR.blog space unfurl. And I still think that's the most important part out of all the things that I just talked about. But all those details that we found in the rest of the URL, I think they matter. So don't overlook the details. I mean, with URLs or with, I think, anything else in a forensic investigation. All right, so we're chatting on Discord with this summit, right? So Discord's a chat application. It can be web-based or it can be a client, either way. But this is a URL of a Discord message. If you right-click on a message, you can say copy link to it, and this is the kind of information you would get. And so I'll talk about this real quick. So the URL is just discord.com. I think they changed it recently to Discord, from Discord app to discord.com. But anyway, that /channels and then /3 really big numbers. That's what the URL looks like. And let's see what Unfurl can do with that. Okay, so it kind of parsed out the Discord, the domain, and then the path. And then it parsed out those big numbers into smaller, it can parse out the information from those numbers. So Discord kind of followed suit with Twitter. I mean, and Twitter was, I mean, they're by far the only person to do that. Twitter's snowflake idea has spawned a whole, there are so many variants of the snowflake used by different companies. The Discord has their own thing called a Discord snowflake. And so it follows in a similar path. There's a timestamp embedded in the beginning of the identifier. And then there's some other bits that Unfurl will parse out, like the worker ID, process ID increment, that again, less are important, but are still there about in the Discord snowflake. So like our last URL we looked at for the Google search, we pulled 3 timestamps out of this. But unlike that, these 3 timestamps are drastically different times, right? The first one's in 2018, the second one is January 2019, and the third one is November 2019. So, okay, interesting. So these are all timestamps. I mean, they're all Discord snowflakes, and they're all parsed the same way. And so we pulled out these 3 different timestamps. But again, doing some research and figuring out kind of from context what these things mean, we can pull out lots of interesting bits kind of about the Discord architecture, I guess. So the way these snowflakes, I guess, in these unique IDs in general work is they're often, the timestamp embedded in the ID is often reflection of when the object it identifies was created. So for here, from this first Discord snowflake, we can tell you that that represents the Discord server that they're on, or that this message was sent on. And so I can tell you when this server was created just from that snowflake. Likewise, the second parameter is the time channel. So you can tell you when the channel was created on this Discord server. And then lastly, when the message that we're talking about was created. And again, like when a message created is pretty analogous to when the message was sent. So that might be the most interesting bit. You can tell when a message was sent just by this URL. But the server and channel parts can also be pretty interesting if you're trying to do more profiling on, like, was this channel created exactly the same time as the server? Is the whole server relatively new or relatively old? So lots of these little bits of context, again, might be trivia or might be really important to your case. So again, just knowing that they're there, I think is great. And this is by far the only URL pattern you can pull out from Discord. Another really interesting one is for if you put the URL of a file attachment, there, again, the ID that represents the file attachment, you can pull out the timestamp from there telling when that file was first uploaded to Discord as an attachment. So again, it's pretty cool. I've seen some interactions with some people on Twitter about looking at things that were uploaded to VirusTotal from Discord, and you can tell, or like malware that was uploaded to VirusTotal and had some Discord references to it. So you can tell when this was sent and all this kind of fun stuff. So there's lots of possibilities with timestamps. Again, like I said earlier, I love timestamps. Okay, and so this is like the fifth last principle I want to talk about is the context matters. So those three Discord snowflakes in the URL were parsed by Unfurl in exactly the same way, right? The snowflake structure is exactly the same, but their position in the URL, like their context, altered kind of what they mean. So I think again, like in with the URLs and with all aspects kind of any investigation, your context matters too. So please don't forget that. All right, we're back to the beginning. Why URLs with the asterisk? So Unfurl can definitely do stuff with URLs, right? Kind of as we walk through. It can do some good stuff with domains, including internationalized ones. So if you ever have any domains that look like they're percent encoded and have this weird funky stuff in there, Unfurl will parse that correctly and showing you like the actual characters that the end user would typically see. Unfurl also parses out magnet links if you do have any kind of like file sharing investigations. Unfurl supports at least a dozen, probably more kinds of link shorteners or short links. And this one is like the one thing I want to call out. Almost everything that Unfurl does is just all local, right? It's just based off transforms for things in the URL. And that's for a lot of reasons, but one of them is, it's kind of OPSEC, right? You don't want to be reaching out to random URLs, right? So short links is the one exception. This reaches out to the link shortener site to tell you what the destination is. It doesn't touch the actual destination. So again, that's kind of a balance of being useful versus OPSEC. So I think it's pretty safe, but you can always disable that if that is a deal breaker for you. And then lastly, with URLs, right, we have lots of these site-specific parsers. So we have ones for Google, or for social media sites, we looked at ones for chat, like Discord. There's ones for email. There's lots for other search engines, other things. So there's lots of these site-specific parsers. We're always working on more, and I'm happy to take requests or help you if you'd like to write your own for a particular website. So I think that's great. But it's not just URLs, right? This was kind of from our examples in the beginning. Unfurl can parse a timestamp. If you want to use it as a tool to translate timestamps into their human readable form, it can do that for you. It translates lots of unique IDs. We talked about UUIDs and snowflake variants, but finding all these different unique ID schemes with timestamps embedded in them has become somewhat of a hobby of mine. So I have a lot of these in here, and I'm adding more all the time. And there's other things like JSON and some compression, like some zip stuff, and base64 encodings, and then protobufs. And so Unfurl can parse all these things kind of by themselves, standalone, but it's also not a coincidence that all these things are things that you would find in a URL, right? Because that is, again, the main focus of URL, but of Unfurl. But you can use it for more things than that. And I kind of glanced over that last one there, protobufs. If I said protobufs and you kind of got triggered a little bit and we're just like protobufs, then you probably looked at them before. They're not the most easy thing to examine. Protobuf is an open source kind of technology from Google where it tries to store key value pairs in a very compact, efficient form. So part of that is that you can tell kind of what's in it, but you don't know exactly the meaning of everything without an accompanying .proto file, which defines what it is. But Unfurl can help you show the things that you can tell from a protobuf without the proto file. And so I'm going to show you a quick example of that because protobufs could use some help. Okay, so this is an example of just Unfurl. So protobufs on the internet, I see them most often in Google URLs, right? Because it's a Google technology, kind of makes sense they would use them a lot. But they're also increasingly common in mobile phone investigations, right? You might find a protobuf inside a SQLite database or in a plist file. And if that's the case, you can copy up the hex from like a database or plist and drop it in Unfurl. So that's what this is. This is just a hex string kind of put in there. And you click Unfurl and Unfurl will parse it out. So the link here says hex plus proto. So it's actually kind of, this is Unfurl's way of kind of skipping a step. It doesn't show you the hex representation or the binary representation of the proto because I don't think that's very helpful. But that kind of hex plus proto is at least letting you know that happened. And then it shows you what that protobuf kind of decoded to. So there's that protobuf with a bunch of numbers. And then again, Unfurl will run against that again, and we'll expand that protobuf into each key value in there is its own kind of node. And then again, because Unfurl runs its parsers against every single node, a couple of those nodes got picked up as timestamps and got translated as timestamps. Again, this is with no knowledge, no advanced knowledge of what this .proto file should be or the definition of this protobuf. But yeah, so this is a way that Unfurl can help you kind of expand or unfurl the protobuf. So hopefully that should help you in investigation. And then hopefully this presentation made you think Unfurl might be useful to you. So I'd love for you to give it a try. So when you want to try it, you have a couple options. The first decision you need to make is if you want to use the interactive version, which I've been showing you here. It's kind of a web interface. You drop it in, you click a button, you can move the nodes around with the mouse, you can change the colors, all that kind of fun stuff. There's also, if you really want to, there's a 3D version of this that I made. I mean, mostly for an April Fool's joke, but you can unfurl things in 3D if you want. And if you happen to have a VR headset, you can actually unfurl things in VR. Again, that's also online. But there is an accompanying tool called the Unfurl CLI, which has all the same functionality as the GUI version. But if the command line is better suited for your workflow, here it is. So the command line, it kind of, I tried to emulate the directed graph kind of tree, a little ASCII art there. And this just shows you kind of the same thing with the command line. It also supports bulk reading from files and writing from files if you want to do a lot of stuff at once. And then, okay, so once you figure out what kind of tool you want to use, you can use it. So if you want to use it right now online, there's a version hosted on my website. So it's dfir.blog/unfurl, or you can go to unfurl.link. They both go to the same place if you just want to play with the online version. If you'd like to get the code and run it locally or do some development on it, it's on that GitHub link right there. If you like using Python, you can just install it quickly with pip install DFIR-unfurl. And yeah, so hopefully you use it. If you have any questions, I'm available on Twitter, or I'll be on the Discord chat, or you can send me an email or GitHub, or I'm pretty easy to find. So happy to take any questions if we have any time.
That's awesome, Ryan. It's kind of funny. I had to chuckle to myself when you said, hey, go try it. I realized that you weren't able to watch the Discord in track one. They've been posting all kinds of stuff into Discord and talking about all the stuff that it does, including unshortening URLs. So I didn't have a chance to try that one, but I guess short links get expanded, which is pretty cool as well. A series of questions kind of centered on this, and I think it's probably addressed by the command line version, but is there any kind of API or other capability, like can the command line tool generate JSON, for example?
So not right now. It just does a text kind of representation of that tree, but that would be a pretty simple thing to add if people want to do it. So you can also unfurl the two scripts I use from command line are very simple. They just import like the Unfurl library and do things. So if you're into Python, you could import Unfurl and use it in your own application to get like a JSON from it. Interesting.
Okay, very cool. Yeah, that's my wheels are already turning on some stuff to potentially integrate this with. What is the licensing on the tool?
Apache 2, I think, whatever the Google one is where it says use it however you want, don't sue us. I think that's the license, yeah.
I like your TLDR. Okay, excellent. No worries there, nor am I. Let's see, another question. Where did that one go? Onion links. Does it do anything special with onion links or any other kind of similar ones?
No, but that would be an interesting thing to add to it. That's a good idea.
Cool. Well, one of the things you mentioned, I believe is key here is, because it is sitting on GitHub and pull requests are always graciously accepted, as I know all of us that work on GitHub are apt to say. Yes. This great framework exists, and now somebody who's got a one-off, very tiny little minute requirement can build upon the existing framework with just what they need, and then reintroduce that hopefully back to the community as well, so everybody can gain it. So that's excellent.
And if you have any requests or ideas, if you want to build your own parser, I am more than happy to help you answer questions, coach you through whatever. Happy to help if anybody wants to write their own kind of parsers for this.
Awesome. No, that is great. One of the questions that came in here that was actually one that popped to me as well was how could it be utilized with analysis tools like Elastic? And my first thought was, oh, this would be an amazing filter plugin for Logstash if potentially translate that out. So that's another idea for integration potentially. Hopefully somebody can pick that up and run with it potentially.
That was kind of the genesis of the command line version. It might make integration easier with a lot of these tools. Like maybe embedding a whole graph might be kind of hard, but having the the text version is the easier step for integrating. So that's kind of why it came about.
Yeah, oh, absolutely. I think that makes good sense. So I guess the last question in here, since we just have a minute here before we go into break, if there's a URL embedded in the URL, so if it's encoded and you've got another URL, does Unfurl pull that nested URL out?
Yes, it should. And if it doesn't, let me know.
Excellent. That is way cool. Good. Well, all right. There's a couple of other questions in here. I'm going to copy paste those into your Discord hallway channel so we don't lose those. There's a couple that are very similar, so I'll try to coalesce those together. But thanks very much. I've followed the project since you had announced it, and I'm really, like even just seeing you walk through it here opened my eyes to a lot of new possibilities. So thanks for working to create it and for sharing it and taking the time with us today to explain a lot of what it can do. You did some great work, and it's going to get used a lot more than it already has.
Great, thanks, and thank you for having me.